All right, welcome to Enjoying Life. So this book that I am reading by John Capobianco. Oh, it's so good. Like it just he gets it. Like he's either been in the real world when it comes to networking, or he's studied it and observed it so well that he just gets what's going on. So just for my own personal sanity, I'm gonna um, read through this because it's actually been a bit therapeutic for me. Because like some of the experiences I've had, it's just like I don't even know why things are so like things aren't going well, and like I can't even explain why. Well, this book explains exactly why. It goes through all the problems of manual legacy approaches to the network, and we read that in the last video. So I want to review that quick. So, and I can do that by uh, uh, can't oh by logging in. All right. Well, none of my comments were saved, which is a problem, and I thought I was smart. Um. Okay. Well, that's a problem. You know what? I can just look back, um, and see where I was. That's the beauty of. Okay, I was at software defined networking. So now I wish I didn't have this extension because. You know what? I'm gonna uninstall this extension because it's not doing the whole reason I installed it. So I don't need it if it's not gonna play nice. So let's get rid of it. So we'll remove it from Chrome. Um, you know what? I will. I'm definitely gonna do this one. This one. So I'll say comment feature is buggy. Comments don't persist. Yeah, and I'll put this one as well. Okay, yeah, sometimes I like to do that. Okay, so and now we can just go right to the file. We don't have to worry about logging in. We don't have to worry about anything. This is a much simpler, better application. You can see it's inconsistent where these dashes are, which isn't that great when it comes to searching. All right, here we go. So as I was saying, sometimes things were going in an unideal way, and like I couldn't even explain why things were, in my opinion, not going that well. So the biggest reason is no source of truth. There's a reason that's at the top of the list because no one can tell you how a device is meant to be configured. And then you get things like the host names are wrong, and there's literally no way to tell what device you're on unless you have the serial number, but no one wrote the serial number down. So you just kind of have to infer based on the devices it's connected to. The descriptions are all off, and there's nowhere written down, or they're written down in decentralized folders, local drives. The people have it for themselves but aren't sharing it with others. So like that's a big one. Same thing with documentation. People have their job, as I talked about John Henry's, who you're up against when you're programming. They have their own procedures and documentations and way of doing things that they're not sharing with other people. And it's like, of course I can't do as well as some others because, and then, it's not a matter of maliciousness too. It's just a matter of like the work is sometimes by, you know, because of the way it comes in, the flow, not any intention or any design. it just happens to land squarely on someone's shoulders. Maybe they're an extrovert while everyone's an introvert. Maybe there's something about their phone line where they get more calls than everyone else. Like, when the work squarely lands on one person and like everyone's just sitting around twiddling their thumbs while one person is working themselves to death, that person working themselves to death has to decentralize because they don't have time to do everything exactly right. Sometimes they have to make a little note. They have to literally go like this and, notepad, and then just like that. And then, when they're working themselves to death, you constantly on, if we talk about actions per minute, which might be familiar to like World of Warcraft players, they're hundreds of actions per minute, while someone else's actions per hour is like 10. So like, those people who are constantly doing things, it's decentralized. Like, and then they're so comfortable with their job because they're doing it so much, they don't even know like how much detail they have to put in the documentation because there's just so much that's missing from what other people do. It's like, do I have to write down every little tiny thing? It's like, oh, I do? Well, then I can't do this business as usual work. Who's going to do that? Oh, the person who needs the documentation is going to do that. Well, guess what? They don't have the documentation yet because I'm supposed to write it. So it's like, these situations, I've had a lot of experience with these situations, and they're, these are everywhere. Like, these are just a fact of networks that aren't automated. Yeah, error prone, that's a big one too. And then the worst thing with this too is like, no matter how good you are, you're going to do something stupid. So the key, as I say with my channel, is you minimize those. So like the stupid thing you do is you forget one time to enable the safeties, and then nothing goes wrong and everything's fine. And then you don't view that as a success, you view that as a failure, because what if it didn't go right? Then you wouldn't have those safeties enabled and everything would have blown up. So that's how I view a mistake. A mistake isn't a outcome, a mistake is a process. So safety is a mindset, and mistakes happen regardless of outcomes. So, and then, those big mistakes, as I said, the person with everything on their shoulders who has all the decentralized documentation because they're making it themselves and they don't have time to put it anywhere else because they're so stressed. That's the guy who knows, that's your John Henry right there. So like, that's the guy who's got to go and fix these mistakes. So it's, it's just like, I would put another thing down here, and I would say distribution of work is another huge key problem, because like, if it's coming in manually, the Juniper guy is going to get all the Juniper stuff. And let's say, your network is all about adding more Juniper devices, and that's 80% of the work. Well, guess what? One guy on your team, the Juniper guy, gets 80% of the work, and everyone else on your team gets the other 20%. So unequal distribution of work is a big one, and I think that's something automation can balance out. All right, so moving on to software-defined networking. Before discussing software-defined networking, SDN, some basic network concepts will be introduced. Theoretically, there are three types of planes, P-L-A-N-E-S, not panes, like window panes, planes, in computer networks: the management plane, the control plane, and the data plane. So in Juniper devices, the control plane and the data plane are separate and connected together with a link. I'm not sure what the management plane is. Let's read all about it. So management plane, and that's the human operator, the tools managing the devices. So that'd be something like the CLI, the SNMP, REST API, or NetConf. The control plane So protocol exchanges with state information, such as OSPF, EIGRP, BGP, and RIP. And then the data plane is the movement of the packets themselves, the network traffic. This would be routing tables and MAC address tables. So routing tables are not routing protocols. Routing protocols fill out routing tables, but that is a control plane activity, actually using the routing table to move traffic. That is a data plane activity. SDN, also affectionately known as oh, that's great. Oh my god. Still does nothing. Okay. This is a top tier book now. Because I never heard it called that, but I've definitely heard wow, okay. This book is in my S tier of Cisco books now. So SDN, also affectionately known as Still Does Nothing, aims to separate. Oh my god, I'm so happy now. Aims to separate and centralize the control plane functions. So it's separating and centralizing the control plane functions, which are protocol exchanges with state information. So OSPF. So these layer 3 routing protocols that populate the routing tables. So it aims to separate and centralize the control plane functions of the network while leaving the data plane functions, so that's the movement of traffic, distributed amongst devices. The management plane, functionally, however, remains distributed and still requires, even under SDN, at least some device-to-device management. SDN has not exactly been the silver bullet magically solving all organizational challenges faced with operating a large-scale network. However, SDN has been given a new life, particularly for decoupling and centralizing the management plane, which is the human operator, so like what you actually do on the device. You meaning the human operator, in the form of network automation. The focus of this book is to show how Ansible can be used to interface with the management plane. Alright, so an important note, any control plane or data plane configurations used in this book are intended to be purely educational examples, not functional network designs, and have been derived from a fictional virtual network. Alright, and that's probably a pretty important note because I'm going to take him at his word for that. This is not a design book, architecture book, so. Alright, so I want to make a new project. I'm going to title it Automate Your Network Lab. So I'll title it Lab. And then automate or automate your network. Okay, so now we've got this workspace here ready to go when we need it. All right, so introduction to network automation. Network automation at its core is the conversion of networks from a collection of independent configurations and transforming them into a unified application. Applications are, before I go on, network devices aren't unified. Like you have these edge ports going to different things. So like how can you unify different things? Well, that's what we'll learn about. All right, so applications are written as code in certain programming languages, compiled and then executed. Application developers around the world use a proven set of methodologies and best practices for software development. A key concept and component of network automation is the conversion of network configurations to code. Network automation exists in many forms using a wide variety of technologies, and it means different things to different people. For this book, network automation is the ability to abstract data from network configurations while using a machine to push commands and templated configurations to network devices securely, lists, and at any scale through a CI/CD pipeline. So agentless is a interesting term. What agentless means is you don't have to install a special program on the device in order to use the network automation. So you can use the things that already exist on the device, the CLI, SNMP, REST API, netconf. You don't have to install a special agent on it. So like Puppet is an example of a agentful a thing that requires an agent because you have to install special software on the device you're managing. All right, so information about and technically, everything. There's no such thing as agentless because like you need SSH, you need RESTconf and all that. So like nothing technically is agentless, but like I guess it means like an agent is like a piece of software specific to the part of the software suite of your network automation, and not like a open source protocol or something that would exist on the device whether or not you were using your network automation product. All right, so information about the network is often gathered through traditional simple network management protocol, SNMP, through simple management protocols combined with NMS solutions. SNMP provides a wealth of information about the network, but is often limited to health monitoring of a device on the network. Most of the information about the logical network is gathered using show commands input by network operators or engineers at the CLI. Gathering information from the network is time-consuming because these commands are nearly impossible to configure. An NMS that is required in order to execute and gather output, especially at scale. So, what if a network engineer wanted to gather all the Cisco Discovery Protocol CDP neighbors on the network to confirm a topology, or confirm the spanning tree information from each device to build a layer 2 topology of the network? What about gathering routing table information to build a layer 3 topology? What if the system could gather all the open shortest path OSPF neighbors? What if the current iOS version of every device on the network could be collected without an NMS, network management system? Which isn't your automation product technically that? I don't know. Gathering this information takes a lot of I guess what they mean is like a proprietary NMS, which I mean, I guess if we have to make an Azure account and give over our credit card. But anyway, moving on. Gathering this information takes a lot of manual effort using traditional network management solutions. Utilizing network automation, network administrators craft Ansible playbooks to perform these tasks by building an on-demand library of utilities. The best part about this approach is that it is completely non-destructive and non-intrusive to the network. Operators are gathering information from the network while developing programming skills and learning the new workflow. At the same time, they are starting to understand the new processes and tools involved in network automation, such as TFS. So they begin using TFS. Work items are created to identify, assign, and track progress on code development. Distributed teams are able to easily collaborate on shared work items. A centralized repository containing the Ansible playbooks, as well as the resulting input, starts to evolve. So they can implement a branching strategy. A single authoritative master branch represents the known working state and configuration of the network. The master branch is protected. Changes are never made directly to the master branch. A working branch per change is created. Developers perform git commits, often within a working branch. Approved pull requests are used to merge tested code from working branches into the master branch. Version control is established on information gathering Ansible playbooks. In concert with the branching strategy, version control becomes apparent. As Ansible playbooks are refactored over time, TFS will contain the change and version history. In addition to Ansible development skills, operators start to familiarize themselves with Git. Alright, so the playbook library. Network engineers can work with the network operations team to find the most common manual methods used for network reconnaissance. These commands are transformed into automated playbooks that operations can start using to troubleshoot or gather information from the network. Working playbooks are easily cloned, refactored, and added to the library by operators or engineers. Alright, so building on these principles, the organization starts to gradually embrace network automation without risk. The power unlock will become evident immediately, and the organization can start considering a wider scale adoption and automating changes to the network. Chapter 6 contains more details and concrete examples that can be used on the network today. There is always risk associated with making changes to the network. Despite the best designs and architectures, some changes are disruptive, and a good example, and outages cannot be avoided. So a great example of that is a bug in the OS release. It's like it literally came from, from the manufacturer of your equipment. They released an OS that has an undiscovered bug in it. So that's a great example. Another great example is like the weather, or like there's a fire in your data center, So this is very much true. All right, so networks also have the largest blast radius in the enterprise. The scope of change impact increases the closer to the network core changes are made. This is an interesting statement because I would think service in the service provider network that would have the largest blast radius. But anyway, for example, an entire building can be isolated from the network. Okay, well, an entire country can be isolated from network with a service provider change. If changes cause an outage at the distribution layer. If the network is down, almost every other aspect of the organization is impacted in some way. Uptime is of the utmost importance to an organization because of the business impact network downtime can cause. These factors can lead to an extremely risk-averse view of network operations. The less change, the better. The biggest challenge in network automation is an organization's willingness to adopt it. Despite obvious benefits, which become clear throughout this book, there can be a lot of resistance to this type of revolutionary change, particularly regarding changes to the network. This mindset is also at odds with the modern pressures and business demands of the network to be, ironically, constantly changing. Network automation is, in fact, a safer and more reliable approach, partly because it all but eliminates manual error. And I need to take a quick break. I'll be right back. All right, welcome back. So, I can't remember any of this. So, I remember reading this. So at the same time, they're starting to understand the new process and tools. So the best part of this approach is, so here's just some challenges you can do. So utilizing network automation, network administrators craft Ansible playbooks to perform these tasks by building an on-demand library of utilities. The best part about this approach is that it is completely non-disruptive and non-intrusive to the network. Operators are gathering information from the network while developing programming skills, and learning the new workflow. At the same time, they are starting to understand the new processes and tools involved in network automation. Okay, I kind of remember this now. Such as beginning using TFS. Work items are created to identify, assign, and track progress on code development. Distributed teams are able to easily collaborate on shared work items. A centralized repository containing the Ansible playbooks as well as the resulting output starts to evolve. Implement a branching strategy. This is for GitHub or like Git. So this is like a branch in Git in a code repository. A single authoritative master branch represents a known working state and configuration of the network. The master branch is protected. Changes are never made directly to the master branch. A working branch per change is created. Developers perform git commits often within a working branch. Approved pull requests are used to merge tested code from working branches into the master branch. Version control is established on information gathering Ansible playbooks. In concert with the branching strategy, version control becomes apparent. As Ansible playbooks are refactored over time, TFS will contain the change and version history. In addition to Ansible development skills, operators start to familiarize themselves with Git. Yeah, so you have the change and the version history of your playbooks, and then you just naturally start to create your own net DevOps department because people just start catching on to what you're doing. All right, so and then the playbook library. Network engineers can work with network operations team to find the most common manual commands used for network reconnaissance. These commands are transformed into automated playbooks that operations can start using to troubleshoot or gather information from the network. Working playbooks are easily cloned, refactored, and added into the library by operators or engineers. So here's another good one for the AI. Okay. So name the top 10 most common manual commands used by network engineers and network operations teams for network reconnaissance.
Certainly. Network reconnaissance is a critical part of network management and security. It involves identifying and mapping network devices, services, and vulnerabilities. Here are the top 10 most common manual commands used by network engineers and network operations teams for network reconnaissance. Ping. Used to test the reachability of a host on an IP network and to measure the round-trip time for messages sent from the originating host to a destination computer. Traceroute, or traceroute on Windows. Shows the path that packets take to get from one device to another, identifying all the hops along the way. NSLookup. Queries DNS servers to find DNS details, including IP addresses of a particular computer, the DNS record, or the DNS server used by the system. Dig. A more flexible tool than NSLookup for querying DNS name servers. It performs DNS lookups and displays the answers returned from the name servers that were queried. Netstat. Displays various network-related information such as network connections, routing tables, interface statistics, etc. ARP. Allows viewing and modifying the ARP, Address Resolution Protocol, table, which maps IP addresses to MAC addresses. Nmap. A powerful open-source tool used for network exploration and security auditing. It can discover hosts and services on a computer network. TCP-dump. A command-line packet analyzer that allows the user to display TCP, IP, and other packets being transmitted or received over a network. IF. A command-line tool used to show or manipulate routing, devices, policy routing, and tunnels on Linux operating systems. HOIS. Queries the WHOIS database to obtain domain registration information, revealing the owners of a domain name or an IP address block. These commands are essential for network troubleshooting, performance.
Okay, perfect. So yeah, there we go. There's a good use of the AI. So building on these principles, the organization starts to gradually embrace network automation without risk. The power unlocked will become evident immediately, and the organization can start considering a wider scale adoption and automating changes to the network. Okay, I remember this. Chapter 6 contains more details and concrete examples that can be used on the network today. And since I remember that, I'm going to pause it and be right back. Okay, I'm back, ready to go. We're at about the half-hour mark, so I can give this another half hour before I move on to something else. So Chapter 6 contains more details and concrete examples that can be used in the network today. Just kind of need that right now, but hopefully we'll get there soon. There's always risk associated with making changes to the network. Despite the best designs and architectures, some changes are disruptive and outages cannot be avoided. Networks also have the largest blast radius in the enterprise. Okay, I remember reading about this now and disagreeing with it. I think they have the largest blast radius in the service provider, which is a Cisco track. So I guess this just kind of leads me to believe that he's just not really that familiar with the service provider track, which kind of makes sense because it feels like a very underdeveloped track to me. I mean, like the tracks that don't have the entry and the associate level tracks feel like, like the enterprise and the security, like the enterprise, in my opinion, is like the main track that like Cisco is like proud of, because you can see it starts with the entry. And then there's actually 2 expert level exams you can take. So like, I feel like what I'm trying to say is like, I feel like this John Capobianco, since he's a Cisco employee and works for Cisco, he's like very strongly biased towards enterprise networking. And I feel like in this case, he's really not considering service provider networking in the way it needs to be considered. And I remember reading this now, but I'll read it again. Networks also have the largest blast radius in the enterprise. The scope of change impact increases the closer to the network core changes are made. For example, an entire building can be isolated from the network if changes cause an outage at the distribution layer. If the network is down, almost every other aspect of the organization is impacted in some way. Uptime is of the utmost importance to an organization because of the business impact network downtime can cause. These factors lead to an extremely risk-averse view of network operations. The less change, the better. So that's true. The other thing that's really important is your network design and architecture. You need to design it in a way so that you can make changes so that the worst case scenario is not a complete outage of your network, but a failover of your network, and that will cause, in a lot of cases, a outage, some downtime, but it will be seconds or less because it's just the time it takes for things to converge after a failover, which could be a long time depending on how your network is designed, but much shorter than a long time, meaning multi-seconds, maybe a minute, maybe a little bit longer than that, not down the whole day. Like that's an absolutely catastrophic scenario, and that's the kind of thing where like I say, to lessen the impact of your failures, we're like that's not your mistake anymore. Like if the network is designed so poorly that one human error can bring down the whole thing for the whole day, there's a point where it's just like an occupational hazard greater than you should be subjected to. Like the people, even the people flying the private jets, like the CEOs, like it said, like this book was written to be read by CEOs and CTOs. So like, you've got problems all the way up the chain to the very highest level if it, if the worst thing you can do is bring down the whole damn thing. Like, the worst thing you should be able to do is disrupt some localized segment of the network or cause a brief outage that results in failover. All right, so next section, the biggest challenge in network automation is an organization's willingness to adopt it. Despite obvious benefits, which become clear throughout this book, there can be a lot of resistance to this type of revolutionary change, particularly regarding changes to the network. And one caveat I want to, with what I said earlier, is when it comes to WANs, like as a service provider network, you're dealing with WANs. In that case, same thing applies. You should only be able to make outages that are temporary and that have a more localized area of impact. But since it's a service provider and the area of impact is a whole country or the whole world, a localized area of impact could be bringing all of North America down for a while. So same things apply to like service provider networking, but just at a larger scale. Okay, so despite obvious benefits, which become clear throughout this book, there can be a lot of resistance to this type of revolutionary change, particularly regarding changes to the network. One other thing I want to say before I'm moving on, and sorry I keep pausing, this book has kind of made me understand more about me and like who I am, which is great. I'm loving this book. I am a service provider network engineer. Like I worked at I have 8 years of experience, 6 of which at a internet service provider, and I attempted the Juniper service provider expert level exam. Like most of my career is WANs, as relevant to a service provider. So I'm biased to think that I'm biased to think about service provider networks. And it seems like the author here is biased to think about enterprise networks. So it's a good thing I'm reading this because we kind of have different mindsets. All right, so this mindset, the mindset of so the biggest challenge in network automation is the organization's willingness to adapt it. Okay, I completely glossed over this. This is like the biggest thing I was saying with like John Henry's and all that. Despite obvious benefits, which become clear throughout this book, there can be a lot of resistance to this type of revolutionary change, particularly regarding changes to the network. Perfect. Okay, so he's addressing exactly what I wanted him to address. This mindset is also at odds with the modern pressures and business demands of the network to be, ironically, constantly changing. So at the same time, you want a network to constantly change, you're hesitant about changing the ways you change the network because you're worried that the change will impact the network negatively. So you want the network to constantly change, but you don't want to constantly change the way you're changing the network. All right, network automation is in fact a safer and more reliable approach. Nowadays it is, partly because it all but eliminates manual error. And they talked about, how network automation used to be done through these like NMS tools, which were like really limited. A lot of times they were expensive. You had to buy it somewhere. And then a lot of times they were complex. It's like you want to do something simple in like HPNA, good luck. And then there's, since it's proprietary, there's not a community, adopting it and talking about the challenges with it and, writing about how to use it better. You have to pay for that documentation. Okay, so making one-time tactical configuration changes is a great place to move from automating network reconnaissance to automating network changes to the network. So that's a huge difference there, reconnaissance versus changes. If you want to get comfortable, if you want to be the automation guy, focus on that reconnaissance, and then once you prove, once you can beat John Henry, then you can move on to changes. A one-time change to the network or a tactical configuration change is something that will be done once and is thrown away. These are often tedious jobs when performed manually at scale. Oversights in design may be found in production, leading to required corrections. Perhaps legacy code has become deprecated and needs to be replaced. Maybe standards or conventions were not followed, leading to a non-golden configuration. Net new requirements, for example, a new dynamic host configuration protocol DHCP server, will frequently arise during normal day-to-day operations. Every organization is different, and each network is going to have unique requirements and challenges. Here are some opportunities for tactical one-time changes that can be automated. All right, I love this. I love this so much. This book is so wonderful. You know what I'm going to do? I'm going to create a GitHub repository for this book because I want to save that. So I'm going to go to my documents and I'm going to go create a new folder. And then I'm going to call it Automate Your Network. There we go. And you know what I might do instead? You know what I might do instead? I'm just gonna pull this. And then or like fork it, you know? Yeah, I'm gonna fork my own copy of this. Let's say grams. What is it? I forget. Capobianco. Okay, so I'm gonna call that. Let's see here. You know what? I might as well just do the main branch only. I'm not even sure if there's other branches. Let me check. Whoops. Yeah, there aren't even any other branches. So yeah, that's fine. So I'm going to create a fork. All right, and then I'm going to go to my profile. So okay, so I can sync it. If he makes any updates, I can sync it. I can contribute really easily. But for now, let me do this. I'm gonna go ahead and go to my documents, and I'm gonna open a terminal, and I want to do this in Bash. It's easier. All right, and then I will pull that down. So I'm going to do git clone. There we go. And then I'll change directory to it. And then I'll open it in Visual Studio. All right. And I have trouble doing that in Wassel. That's okay. What I can do instead is I can exit. And then I can go into CD automate your network. There we go. LS. There we go. That's the one. Now I've got two of them. I created my own, I think, but I can do Visual Studio like this. I did make my own file, I think, that said automate your network, but it looks like I overwrote it. So I don't, yeah, I overwrote it, so we're good in that regard. Now we got Visual Studio open. We have this file. I'm not sure what this file is. Looks like there's 1, 2, 3, 4 files I pulled down, and then there's 1, 2, 3, 4 files in the repository. So I'm just gonna delete this file, and it looks like this file's in green, so it's not part of the repository anyway. If we go to the source control here, we can see this is a change to the repository. It's an addition of this file, so I want to undo that change. There we go, and now we no longer have that file, and thus we don't have any changes to the repository. So the first thing I'm going to do, of course, is create a branch and say, so I'm going to say get checkout -b to make a branch. I'm going to say Graham's book read through. Okay, and then I'm going to make sure that I'm in that branch. So get branch. Yep, so I'm in that branch. Another way to check it. I mean, this is okay. Down here's a way to check it. So we're in this branch, so you can. I'll switch to the main branch again. There we go. We're in the main branch. Okay. Okay. I clicked this synchronize instead. So I don't want to click that. I want to click this here to change the branch. So now I'll change it back. There we go. And we can do here. We can't synchronize it because this is here. But let's go ahead and publish the branch to my thing, and then we'll create a new file. We'll say book read through notes, and make it a text file. Okay, there we go. And now I want to add to my notes. I want to add here are some. Yep, perfect. I'm really, really enjoying this book. Okay, so here are some opportunities for tactical. Okay, there we go. The other thing is, okay, so there we go. Correcting errors, there we go, and then net new projects, there we go. So so one thing we can do is and we'll read it from actually let's do this. So we're gonna go here. Now we see there's a change, so let's look at what this change is. It's adding this file and filling this file in like that. So let's commit the change. Oh, sorry, let's stage the change for commit. All right, and then let's commit the change. Okay, so here's the commit message. We'll say adding important notes from first read through. Okay, adding from read through. I hate that menu. I wish I could get rid of that. Okay, so that's good. We're gonna save that and close it. There we go. And now we have a change. So if we go here, we can see our timeline. The first thing we did is save the file. Then we added an important note. So let's update this again. Let's gonna do page 16. We'll put the page of it. So we're gonna say page 16. All right, perfect, love it. Now I want to do another note before I move on. And this is hopefully it's clear what I want this to be. but I'm gonna. Okay, yeah. So the other thing I want is um, yeah, I want basically all of these things. So first thing I want is the operational challenges. So I want this brief list of problems with the legacy method of managing a network. Um, so that was on page 12, I believe. Yep, that starts on page 12. So paste that in there and clean it up a bit. So no source of truth, that's a big one. Yeah, that's a big one. Documentation, that's a big one as well. Especially the centralization or decentralization of it. It's just hard to get centralized documentation when the burden of work is is distributed in an unequal way. You tend to have unequal documentation. The people who are doing the work keep their own documentation to allow them to do it more efficiently. Whereas if you had automation, everyone could do the work equally because the natural division in expertise isn't relevant anymore. You're just running, a tool. So, yep, limitations of available. Like, for example, as I mentioned, somebody knows Juniper. They're the only person in the floor who knows Juniper. They get all the Juniper stuff, and guess what? The Juniper stuff is 90% of the work that comes in. Well, I guess they're doing 90% of the work then. Unless they can update the documentation, but that's not too easy either because now they're doing 110% of the work. They're doing an extra 20%, which is updating the documentation. And then while they're doing that, nobody's doing that other 90%, so now they gotta catch up. Ideally, they write documentation so good that it makes up that difference because now other people can help out where they couldn't before, but that's an ideal situation, which are sometimes hard to come by. All right, so this I definitely wanted to save. The other thing I want to save is so understand the new processes and tools involved in network automation, such as I want to have a clear definition of what this new management method is, and this is what it is. It's TFS, it's branches in a code repository, it's version control, and it's Ansible playbooks. All right, so this is on page 15. So that brings us to page 16, and this is where I'm going to start reading next. Page 16 is good. I already wrote this down, so it's going to be page 15. And then we're going to clean this up. So basically the first thing you need to do is start using TFS. Let me ask the so when it comes to software develop, what are some examples of free and open source TFS applications?
Certainly. It seems like you're exploring different tools and technologies which can be beneficial for your upcoming job interview. Understanding various tools can give you an edge in technical discussions. TFS, or Team Foundation Server, is a Microsoft product used for source code management, project management, and build automation. However, if you're looking for free and open source alternatives to TFS, here are some examples. Git, a distributed version control system that's widely used in the software industry. It's free and open source. Apache Subversion, SVN, another free and open source version control system that's centralized, unlike Git. Jenkins, an open source automation server that can help with build automation, similar to TFS's build features. GitLab.
Okay, so I think they're talking about Git. Basically, they're just using. See, I think of Git as like a version control tool, but maybe it's multifaceted and does TFS as well. I'm not even sure what TFS is. So, what is TFS?
Foundation Server, TFS, now known as Azure DevOps Server, is a Microsoft product that provides a set of collaborative tools for software development teams.
Okay, so TFS is Azure. I remember. So that means you got to give it your credit card number, even to use it for free. If you want to use any of the other thing is like it's got you now. Like you're dependent on it. So like if they change the pricing, if they do anything that, like okay, great. Do you want all your files? You want all your things that you put on? Pay. So that's what TFS is, and that's what this book will talk about. But there's alternatives to TFS. So name the best 3 alternatives to TFS. So GitLab, these are like I'm using GitHub here. CI/CD. So like, yeah. So the other thing, yeah, like Jira and Bitbucket. That's what the Azure DevOps Server is. And these are, I think, it's just an alternative tool to this sort of thing, and you have to pay for this sort of thing anyways. Some of them are free, but some of them has features, so it's the same deal. Where we are in a kind of revolutionary phase is we can use this thing and say, write me using Python 3. So using Python 3 and any other tool that is relevant, write a program for me that I can use instead of TFS. I want to have full control and ownership of every product I use. Therefore, using a product owned by an external entity such as Microsoft is not an option for me.
Creating a complete alternative to
Oh, okay. Well, maybe it's not
TFS,
that easy.
Azure DevOps Server, is a substantial undertaking, as TFS encompasses a wide range of functionalities, including version control, build automation, project management, testing, collaboration, and release management. However, I can guide you through setting up a basic system using existing open source tools and Python scripts to handle some of the core functionalities. Here's a high-level overview of what you might need. 1. Version control. Git. You can set up a Git server on your own machine or network to have full control over your code repositories. 2. Continuous integration, continuous deployment. CD, Jenkins is an open source automation server that can handle building, testing, and deploying your code. 3. Project management. Redmine or custom solution. You can use an open source project management tool like Redmine or build a custom solution using a web framework like Django or Flask. 4. Custom scripts for specific functionalities. You can write custom Python scripts. Here's an example of a simple script to automate the process of pulling the latest code from a Git repository and building it using a makefile. This script assumes that you have a makefile in your repository that defines how to build your project. Conclusion: building a complete alternative to DFS would require a significant amount of development effort and expertise in various domains. The above approach provides a starting point, but a full-fledged system would likely involve a team of developers and several months of work.
Okay, so this is where you could probably use like GPT engineer, something like that. But you pay when you use that, so it probably using Azure or whatever is probably fine. Okay, so let's finish editing this. The other thing with like Azure is like, the Microsoft people know what they're doing. So like the latest and greatest AI product or whatever, it's going to be right there ready to go if you have already got yourself set up in Azure. So like, being like too isolated is like its own problem. Like, being out there ready to go, ready to adopt new technologies is can be worth it, especially if your network is very large. All right, so now what we're going to do is go to the source control. We're going to stage these changes and we're going to commit them. Here's the commit message. So it's going to be further notes added. And then I'll do Control S and I'll close this. So then what we're going to do is push these up to the repository. Click OK. Hopefully my SSH key is up there. Yep, it is. So now if we go to the repository and we refresh it, we can change branches to my read through. And then we can see my book read-through notes. Okay, so the next thing I want to do is go to this file and look at the timeline. So we can see it tells you when the file was saved, and then we can see the notes that were added to this file. No changes beyond adding those notes. Nothing was modified and nothing was deleted. As part of the repository, have a place for one-time tactical Ansible playbooks. These playbooks will become part of the larger network automation framework and are available for cloning and repurposing. Examples of successful plays helps others develop their own playbooks and code. Chapter 7 has several cases of one-time tactical plays that can be used as a foundation to solve unique challenges. Perfect. At this point, the organization should be comfortable with using network automation for information collection and making changes to the network. While these are both great capabilities that will completely change network operations, the real power of network automation is full configuration management coverage. Every device is configured by the network automation engine using dynamic templates powered by abstract data models, essentially converting the network configurations to code. This code is intent-driven data models in human-readable format comprised of variables and dynamic templates that contain the configurations. Version control can now be implemented using Git. The compiled configurations are then pushed to the network through automated Ansible playbooks. Chapter 8 covers this in more detail. Creating a CI/CD pipeline is the last step to fully automating the network. Automated builds, tests, and releases are now available to network operations. As part of the branching strategy, builds can be triggered automatically whenever pull requests merge code into the software branch. CI, this is discontinuous integration. This stands for continuous development. Releases can be scheduled and deployed to the network, much like a patch to software is released to applications. Scheduled releases can occur at any frequency, hourly, nightly, weekly, monthly. Approved changes are merged into the master branch in the repository, which automatically triggers the development during the next scheduled release, which is a deployment. This is the full power of network automation unleashed. So the full power is builds can be triggered automatically when there's a pull request. Then the release can be scheduled and deployed. So you no longer need a night team to actually plug them into the devices. It does that automatically. And then you can release them on a table. So you can do, your reconnaissance every hour. You can do your major changes every night, and then you can do larger traffic analysis or whatever you want to do every week. And then you can do a full refresh of your entire database every month. So, and you don't have to waste man hours doing that, or worker hours doing that. It just automatically comes from your network automation. All right, so the next section is impact on IT, and I will pause it and be right back. All right, I'm back. I'm at the 1 hour mark. That's usually, I think, a good time for these videos. So let's try to get... okay, well, there's still a lot left. So I've got lunchtime coming up in about 11 minutes. So let's just get up until lunch, and then I'll have lunch and move on to probably a Linux video. I don't know. I've got a full day. Work day is typically 8 hours, so this is an hour. So got about 7 hours. Okay, so impact on IT. The impact on IT should not be underestimated. There is a lot of change and learning involved. It is not just the tools or new file types or data formats, but the very mindset of IT itself, which can be very hard to change. And, not just hard to change. It's we're talking about John Henry here. He's good at what he does. If your machine pounds the spikes in at an angle, pounds them in too far, pounds the railroad spikes in too shallow, doesn't adapt to the soil. Let's say that the railroad spike it hits a rock and it chips in a certain way, and it kind of ruins the spike. It doesn't use a different spike. It just keeps using that broken spike. It's this is what I mean when John Henry knows what he's doing, and everyone loves John Henry, and you have to beat John Henry. So it's not only do you have to, is the mindset hard to change? The mindset exists for a reason. Mindset sometimes is impossible to change. It's even with machines, you're going to have to do quality control. You're going to have to oil the machine. There's a point where it's okay, John Henry's awesome. We love him. He does this thing amazing. Okay, great. Now we have a machine and he can play RPGs and stream on Twitch instead of hammering in railroad spikes, but this maintenance on the machine is awful. This is more work for more people than John Henry was doing himself. So that's a hard challenge, and I would go as far as to say that not only can it be very hard to change, it can be impossible to change or impractical to change. And I would even go further than that and say it can be a better way of managing your network than automation. Automation's not a silver bullet. It can be legitimately better to have a team of John Henrys do something than, a steam-powered machine. All right, so acceptance of innovation often faces risk adversity. Yeah, that's the other thing. The moment your automation does something bad, they're going to pull the plug on the whole darn thing, no matter how good the rest of it was doing. And a natural resistance to change. Network automation will absolutely lead to changes in core processes for change management and network operations. And you know who's in charge of network operations and change management? Your director, the CTO, the CEO. So you're telling these people who fly around in private jets, I know how to do this better than you. It's like, no, you don't. You don't. So it's like you got to come at this from a mindset where it's not about me. It's about John Capobianco. It's about the modern. This book is written for CEOs. It's about the content in this book. It's like, this makes sense because the people you pay millions and millions of dollars to say that it makes sense. And yeah, it's not me necessarily, if you want to think about it that way and promote me to director or CTO, great, I'm not going to complain about that. But, this is not a matter of one of your low-level employees thinking they're more special than they are and being a risk to the network. This is a matter of implementing cutting-edge network management tools that have to be implemented in order to keep up with the competition. All right, so acceptance of innovation often faces risk adversity and natural resistance to change. Network automation will absolutely lead to changes in core processes for change management and network operations, the things done by your CTO and CEO. Network maintenance will be automated, and this could mean some restructuring or refocusing of staff, another thing done by your director, CTO, and CEO. So this book, this is for the first thing they listed in who this book was for was the CEO. The next thing they listed was the CTO. So this is big stuff. This is not something to be taken lightly. If you become an expert in this and you can beat John Henry anytime, there is a world out there, and this book is not going to prepare you for that. You need to learn leadership skills. You need to read books about what it takes to be a good director, CTO, CEO, and you need to be prepared for this risk adversity and natural resistance to change. So network maintenance will be automated, and this could mean restructuring or refocusing of staff. The only thing that can break network automation is manual intervention, and therefore it is imperative that everyone involved in the network fully understands and is on board with the new direction and processes. Manual changes are in direct contrast with intent-based networks and will be overwritten by the automation solutions. That said, a balance must be struck. In an emergency, the CLI will never be replaced. However, be sure to track all out-of-band changes applied to fix the issue. Retroactively include these changes in the code repository as an out-of-band emergency switch. All the manual emergency changes should be captured and incorporated into the repository. I have about 4 minutes left, so next section is Net DevOps. Net DevOps builds on the DevOps model from the application world, but is applied to the networking foundations of an organization, the network developers, senior network engineers, architects, and designers, and the network operators, network administrators, network support staff. Day-to-day network operations are blended under a new framework. The senior developers are empowered to deliver into production directly through release management using pull requests. The operators team updates the data models and executes playbooks for routine network changes. Operations most likely will not write or update the dynamic templates. Templates will be developed by the senior network staff. In the case of net DevOps, benefits can be found by having software developers join this new team to help create the data models and templates with the input from the network team. Blending IT and blurring the lines can lead to questions of where authorized changes come from. Fortunately, the automation engine itself is making the changes. Approvals should now look like peer reviews of code and traditional quality assurance QA, as changes are now code-based. The impact to the network operators is tangible. Operators learn to write playbooks to help run the network, identify problems, and troubleshoot. Most network changes will be automated to much easier tasks, such as running an Ansible playbook as a single line command. Using the features available in TFS, which is like Azure, Operations now has a version control available in the form of pull requests and git commit information. Change approvals are built directly into the pipeline, allowing for automated delivery of solutions. All right, I've got about 2 minutes. That's enough time for the next section, which is skills. Converting the network team into a development shop takes time, practice, and training and support from the organization. Staff will continue to require essential network training while learning and developing their programming skills. The code itself will improve over time as skills are polished. Code is easily refactored once better methods or improved logic develops. The best way to improve these new skills is ideally to try and fully automate a lab environment if one is available. Having a lab environment where staff can safely troubleshoot allows them to develop without fear of causing an impact to production. Code should only interact with the production environment after it has been fully vetted and the effects of the implementation understood. Once the code is fully tested in a safe environment, it can be ported over to the production environment worry-free. All right, so next section is tools. Don't have time for that. That's going to be it for this video. Thanks for watching, and stay tuned for the next video.